Okay, so one more thing I forgot to add, of course, was a cylinder, one of your basic prisms. The volume, of course, still being the area of the base times the height. So knowing the height of this prism and the radius of the base, I can always find the volume. Okay, so for the sphere, it's 4/3 pi r to the third. Of course, being three-dimensional, 4/3 pi r to the third. So all I need to know is one of those dimensions, one of those variables, because of course all balls are similar. It's all a function of the radius. All the other variables are fixed. Now, the volume of prisms, again, we classify this as a cylinder, but it's similar to a prism. So once we find the area of the base is a circle, so pi r squared is the area of the base. And then we multiply that by the height, hence pi r squared h. That's the volume. Now, let's look at the pyramid. 1/3 base times height. Now, notice the capital B, okay? The capital B stands for area of the base, okay? The pyramid has a base, so we need to find the area of that base. Once we find the area of that base, we multiply it by the height, the distance from the base to the vertex, 90-degree perpendicular. That is the height. So we'll find 1/3 of that. Pretty easy stuff. Just plug your numbers into the formula. Here, all you need to know is the radius. They give you the distance all the way across, divide that by 2. For the pyramid, the area of the base, which in this case, of course, is a square, let's say is 3, so that would be 9, 3 times 3, it's a square. And then the height, let's call that 4, so 3 times 4 is 12, 1/3 of that is 4, so volume of that would be 4 units with respect to these numbers being used. For the cylinder, volume is pi r squared, which is the area of the base, and then times the height. And you get your numbers. Now for the sphere again, it's 4/3 pi r to the third. So pi times pi times pi, radius times radius times radius, then times pi, then find 4/3 of that. Or some people like to do multiply by 1.3, but it's up to you. Questions? Let's work out some problems using volume. The infamous 3-dimensional ice cream cone.